Okay, yes, I guess we can start. So welcome to Madara Community Call number 6. I would like to start by, talking a bit about the people behind Madara and the amazing community and people we have. I was saying that I really loved all the stories that you guys shared in this GitHub discussion. I encourage everyone to read those stories. They are very interesting, very exciting people, and also some fun stories. And I would like to start, talking about those people a bit during the community calls. So I will try to have 1 or 2 people per community call to share a bit more about them, so that we get to know each other and whatnot. So Clément, if you would like to start, that would be amazing. Clément?
Yes, I need to quit different things on my computer, I think, because it's somehow saturated with.
No, it wasn't you, no worries.
Oh, it was on my side?
Yes.
Oh, is it better now? Or?
Yes, it's okay.
Okay, so you completely missed what I said, or what?
No, we heard you, just saturated a bit.
Okay, sorry about it. So Clément, you want to say a few words about you and your story?
Yes, just a few words. So I don't know exactly. Yes, I'm definitely in between, I would say, science and engineering. So this is somehow what I wrote. I have, of course, some classical background, I would say, in applied math. But on the side, I've always done quite different kind of projects. I think that whatever, I don't know, I'd like to dig into whatever is somehow in front of me at some point. So, of course, I did math, I did informatics, computer sciences, but also like sewing, sports, leading things, writing. So it's just like, I don't know, I like to discover new things and stay a bit around. The difficult part for me is, I think, to stay longer. So, for instance, the PhD was 3 years, and I did more like 2 years, 2.5 years than 3 years. So hopefully now is I'll stay in Starknet. I've been Starknet for a year, so I hope I won't get bored in a year and a half. Who knows? No, that's the difficult thing for me.
Okay, and I saw that you like football and that you were leading a football team.
Yes, yes, actually, 7 players football team. I did that for like 2 to 3 years, or maybe more, 3-4 years, and then I passed to some others to continue the team. The team is still playing. There are actually several teams playing Monday evening. So no, it's nice. I stopped because I started to play tennis instead, and now I'm
Okay.
So
maybe
yeah, I mean, it's good. Yeah, it's good to change. It's like the haircut. Sometimes it's short, sometimes it's long. It's like the bear. Sometimes it's short, sometimes it's long. And not always the same thing at the same time. I like it. I like it like that.
Okay, and as I said in the comment, maybe we should organize football tournaments during Starknet CC.
Yeah, that would be awesome.
Yeah,
we would get the revenge against all the people from Latam.
and
stuff.
Yeah, definitely.
You know what I'm talking about.
Okay, and last thing about you, I want to do a shout out to Kakarot team for the press announcement. So congratulations for that. This is amazing. Sorry, can you mute, please?
José.
Okay, I muted him. Sorry. So congrats for this. Yeah. If you want to share a few words about that.
I mean, you know that it's, of course, a pleasure to hear congrats from yourself. You know that you're far from being innocent into this success so far. So cool. Yeah, thanks a lot for initiating this project for sure. We know it's just the beginning. We have good people having a lot of expectation about this to really change the Ethereum, I would say, scaling on the long run. So hopefully we'll keep working all together, and especially here with Madara. I'm here with Madara, but also because it serves Kakarot. So I like the fact that lots of projects are just working all together. So we don't need to redo everything by ourselves. We just can jump into a project for a couple of times, follow it, help it, and then it helps the other as well. And after a few years, we will have a constellation of few projects, really top-notch projects that will make StarkNet overall the best place to be, hopefully.
Yeah, I really love this collaboration mindset we have in the ecosystem. This is amazing. Okay, so thank you, Clément, for sharing a bit about you. You will speak later during the call about the benchmark infrastructure. So the agenda for today will be a backlog review and task updates. Then Timothée will speak about the plan for Cairo 1 support, because for now on Madara we support only Cairo 0 smart contracts. We will speak also a bit about coding practices. We want to start initiating clear concepts and principles we want for Madara, and I think in general for the whole ecosystem in general. And I would like us to first here introduce the idea, and then during the next community calls, we can deep dive on some concepts with very concrete example on the code base. And eventually we can even do something like, for example, take an existing pull request and see how we can improve it by applying the concepts and principles. That can be interesting. Then Clément will talk about the benchmark infrastructure, how we measure performance of Madara, what can we improve, and what is the goal behind that, and the tooling we use, and whatnot. Then there will be 2 deep dives on 2 RPC implementation. One is StarkNet Get Events by Greg, and the other one is StarkNet Simulate Fee and not Invoke Transaction by Ben. Okay, I guess we can start by a quick backlog review and task update. Matthias, you want to start?
Yes, sure. So on my side, I didn't have too much time this week, but basically I'm working on 2 things right now, fixing the RPC contract class method. So there is like a related issue in Cairo RS. So basically the issue is that right now get class and get class at RPC endpoints just don't work. They return some default contract class. And that's because of the way we have to serialize the contract program and everything, which was not easy. And we had a lot of discussions about types last week, which was kind of related to that. And now the problem is that we're able to deserialize the program structure to bytes, but not to serialize it. So take the bytes and put that in a structure object. So yeah, so I have to write this part in the Cairo Rust repo, then cross the fingers so it gets merged as soon as possible, or we can do it on our fork. I guess we'll see. And the second thing is about the class hash. So computing a class hash from a program is pretty, I mean, in Cairo 0, it's a bit weird. Like there are some, it's not like deterministic. By deterministic, I mean, if you convert a program to a class hash and then in the other way around, you might not get the same result because there are some ordering problems, like in the JSON contract artifact. Yeah, so I'm working with Jonathan to see how we can also handle that the best possible. With Cairo 1, it's way easier. They fixed this, but yeah, since we are going to support Cairo 0 for some time and for I think always, we need to handle this. Yeah, and this is linked to fixing basically the declared transaction endpoint. Okay, I see that Timothée wants me to do it on our fork. Okay, so I will do it on our fork then. Yeah, and then the big thing I'm working on is the state root. So that's yeah, I've been studying the Pathfinder implementation this week to see how I can approach it. Yeah, it will be just like for the transaction and the event commitment. There are a lot of we can just copy and paste the Pathfinder implementation. So now I think I have a good idea on how to implement it. I'll be able to do it next week.
Very cool. I want to add something on something you said about the difficulty around types for Rust. So indeed, it's a big pain in the ecosystem. So we started a an effort to try to standardize and converge to a universal felt representation in Rust. And hopefully we will have it soon. And the idea will be to have the core Stark felt representation and a single one, which will be obviously the most optimized and performant one. So Lambda class and Jonathan and people are working on benchmarks to see what is the best candidate for this universal type. And then hopefully we can converge and all use those new types. And it will be easier because, for example, on Madara, we are using many dependencies, StarkNet RS, Cairo VM, Blockifier, and all of them are using different Rust types. So indeed, it's a big pain. So hopefully it will be better once we have the universal Rust type. Okay.
Yeah, just on this, I don't know if Lucas, you had time to generate some flame graphs and everything, but the last time I spoke with Lucas, it was type conversions was like the thing that took the most.
Still the case.
Yeah, okay, yeah. Still the case. Okay,
yeah,
so definitely will help a lot with performance then.
Definitely. Okay, then Chirag, you want to go next? Otherwise, I can give Greg.
Yeah, sure. So this week I was mainly working on Git events that are all present later in the community call. And what I've been, I think for the rest of the week, I'll be doing some light cleaning. We did find that, I think one of the problem we have, and I made an issue for this, is that a lot of the transaction hashes and the of some of the addresses encoded in the StarkNet palette tests are hard code values. And that was actually causing a test for deploy Bravos account to pass, even though the transaction hash wasn't correct. It was a weird bug, so discuss with Lucas, and we might just remove the testing with Bravos because of this issue. Yeah, and I think basically we'll be cleaning for the rest of the week. That's it for me.
Okay, thanks. Harsh, you want to go next?
Hello. Yeah, so I'm on. Okay, yeah. So for me, I'm working on benchmarking ERC721. So I went through the existing benchmarking code, and I initially thought that might be we can pull off the ERC20 from the Genesis state as well. But I had the conversation on the Telegram group, so I guess that will remain the way it is. And now I'm working on a pre-hook which could deploy ERC721 and then benchmark it. So yeah, I'm working on that part. Yeah.
Okay, thank you. Lana?
Hi everyone.
Hi.
Yeah, so from last call, I did a bit of chain spec cleanup storage from the hard-coded keys, and now I have a little PR to merge the block transaction because it's an enum that has hashes and full transactions, so to just like merge it into one like type. And I also been investigating potentially adding Beefy to Madara. We discussed it with Matt, and he asked me about the performance of Beefy. So I'm trying to investigate if it's fast or slow, and if we need it at all. So I might just need a bit like help to, you know, to decide what to do with it. But and one more question I have is, you know, there's a couple of to-dos in the palette itself about the weights. The weights are all 0 and all the origins are none. Is there something blocking from doing it? Because if not, I'd be happy to tackle that.
Yeah, okay. So I guess we just need to remove the to-do because basically we cannot use the weight system because of the account abstraction of StarkNet. So we will continue to use only 0 weights on all extrinsics, basically, because of the account abstraction mechanism on StarkNet. We cannot apply weights, and we cannot use the account system in Substrate. maybe we could think about somehow using it for the fee computation, but it will be very hard, especially because we delegate the fee computation to another component, which is the blockifier, and this is a dependency. So it might be hard. I don't think we will be able to do that. This is the reason, but I guess we should make it very explicit and clear that this is on purpose, and we cannot do, we don't have the choice for the moment, and maybe it will stay like that even in production because of the account abstraction. So obviously we need to couple that with some DOS protection because otherwise you can just spam the sequencer. But yeah, we need to, we cannot do signed origin as well for the same reason. Don't forget that on StarkNet we have the account abstraction, so we cannot assume that all extrinsics will be signed in the same way or even signed at all, because you can have some accounts that don't even need a signature, a cryptographic signature or some or what. So because of the account abstraction, on the protocol level, we cannot use signed origins as well. Okay, but I guess we need to write a document about choices about that, and the mitigation maybe we can try to find. It's an important topic.
We could add maybe like some fixed weights to it. Maybe we could distribute some kind of weight token to people to, basically to protect from people abusing it. But okay, we'll talk about it later. Then I see my former colleague from Parody, Justin, is also like 0 weight sounds wrong.
Yeah.
Okay.
Yeah.
All right, thanks.
And yeah, we'll be happy if you, Justin and Lana, if you come up with some solution, we'll be happy to use weight system if we can do it properly and integrate it with the account abstraction mechanism. We'll be happy to hear from you guys because you have obviously experience in Substrate. Okay, very cool. Thank you, Lana. Zé Diogo, you want to go next?
Yep, sure. I don't have anything much related to issues to add, apart from adding the Substrate tutorials that Timothée sent me some time ago. I'm currently solving them. Just probably also everyone that also wants to learn more about Substrate should also do them, because I've been finding them very helpful. And yeah, it's pretty much that on my side. And hopefully when I finish those, I get to have more context regarding Substrate and contribute on different levels.
Amazing, thank you. Pia, you want to go next?
Hello. I think this is first time to join the community call because I
Welcome.
thank you. I committed like right few days before. So I worked at changing the error type into derivative. That was my PR. And then right now the Zhuang gave me the one of the first code issue, which is I was like, I'm taking a look at it like this weekend, start from this weekend. But it's like adding a one RPC related. Yeah, I'm taking a look at it. Yeah, so I think I hopefully can finish it like until next week, and like thinking about what can do with Madara. Like I asked questions on the Telegram group, like some is it like possible to like interact with other stacks like OP stack, or like how would be the Kakarot related like L3 will look like. So I just like to like discuss this kind of topics with you guys. Yep.
Yeah, definitely. This is a very interesting topic, and I think we can allocate a full community call about it next time, because it's a very important topic and very interesting, and we really want maximal modularity for Madara, and we encourage people to build on top of it and integrate with other solutions, other data availability layers, other stack as well. And yeah, the coupling between Madara and Kakarot could enable to run the OP stack on Madara on Kakarot. on Kakarot through Madara sequencer. So yeah, this is definitely an interesting design space. We need to explore more. And the hackathon run by Pragma will be a good opportunity for people to try and explore those things. But maybe we can, before the hackathon, talk about them and start to draft some idea and guidelines for people who want to hack during the hackathon and explore those ideas. Okay, very cool. Thank you very much. Okay, I guess that's it. We can go to the next topic. Timothée, can you give an update on the plan for the Cairo 1 support and the challenges we are facing?
Yep, sure. So basically, Blockifier updated its code base, supporting Cairo 1 contracts. So what we want to do is to rebase our dependency, to upgrade our dependency to Blockifier in order to support Cairo 1 contracts through them. The problem is that, as you know, our runtime has to be compiled without the standard library, what we call a NoSTD mod or NoSTD. And the core repository in the ecosystem don't really support this. So we had to fork them. I'm talking about the Cairo virtual machine, Cairo VM by Lambda class. They used to support it after some change we did, but they introduced some change that broke this compatibility. And Blockifier, same, we are using a fork. Basically, we fork Blockifier, and in this fork, we use our fork of the Cairo virtual machine. And now the thing is that Starkware developed some Rust libraries. Like, you know, before Cairo, it was a Python library. Now it's Rust one. And those traits, Blockifier and Cairo virtual machine, started to depend on those Starkware Rust library, which are like the core of the language. And those don't support NoSTD compilation. So we could add a third fork to our list of fork, but it starts to become like impossible to maintain and kind of dangerous and also really heavy to maintain. But people at Starkware heard us and agreed to rework their libraries so that they support NoSTD compilation. And that's what I'm doing right now. I'm merging pull requests to the Starkware Rust libraries, so we can compile those traits in NoSTD. So then we can use those in Starknet in the Cairo virtual machine by Lambda class, and then in Blockifier, and then in Madara. And once everybody is back to NoSTD compatibility, we can have our new stack with Cairo 1 support.
Yeah, and in a month you will say us and not them anymore, talking about Starkware. If you want to talk about it.
I will. I'm joining Abdel team at Starkware, and I will start like officially on the 3rd of July.
Congrats, man! I'm very happy. Very cool. Yeah, Clément, you want to go next to talk about the benchmark infrastructure?
Yes, sure. So I've actually taken this GitHub action from a Lambda class, but as you may know, we now have automatically deployed on the Madara GitHub page the benchmark, so that are defined somewhere else. I think the benchmark were initially written by Luca, if I'm right. So the benchmark is the TPS and the number of extrinsic block. So yeah, I don't know if you want me to just give you more details about how this GitHub action works, or maybe just.
Yeah, I think this is interesting. Yeah, we can.
So let's go to the Madara repository. Maybe I should share the screen myself.
Yes, please.
The desktop. And not my personal messages. Hopefully. Okay, so here, So basically, we have the one of the workflow here. It's called benchmark, and it uses this GitHub action called benchmark GitHub action. And actually, what this action does is mainly running whatever is actually either it's not running, it's using whatever script, whatever metric file you want to use. It's a JSON file with a simple, how do you call that? A simple list of dict with value, name, and stuff. We can open this action as well, if we want. And then it will produce a plot, commit after commit, it updates the data. What you need to know if you want to use it is that there are some bugs. So right now this configuration works, but if you want to have it committing everything and stuff, it may not work. And anyway, so we run here the benchmark as before, and we use the script here. It can work out of the box with a different kind of outputs, output by the usual tools in Go, Rust, Python, and stuff. Because we generate a custom benchmark, we just use the custom, bigger is better, for instance. And the JSON file is a file with it's a list of value and name value. And then, yes, we say that we push the result only if we are on main, that we push a summary if we are on main, and we can see the summary in the action page. Here, if you're on the action page, the benchmark, you go to one of the benchmark. No, this is not main, so there is no summary. If we go to main, here we have the summary of the benchmark. Okay. What do you want to know? Maybe if you want to use it, you can customize the rendering. So let's open the benchmark. So now we have here a simple page with, I don't know what happened to the TPS actually.
Those are failed transactions. We need to fix that because we need to count only successful transactions. So yeah, there is no 2x improvements at all. This is just that we have failed transactions. So they are faster, obviously. Yeah.
So in any case, by default, whatever you dump in the metrics, in the step here, in the metrics JSON file here, is actually happened to a data file automatically by the GitHub action, and then it adds a dot, and it put one plot per metric. So if you want to have 10 metrics, you just have one single plot per metrics. But you can, if you want, tweak this. So actually, it uses the GitHub GH page branch, which is the branch used for the GitHub page. And here there is this dev bench folder, which is exactly the same as the one that we have here, Madara/dev/bench. And the action generated the first time an index.html page, which is the page that we see here. So it's a pretty basic page, and it's just a static website that pulls the data from this data.js file. So at the end of the day, the data.js is what is actually updated by the, I would say, the GitHub action. And if we want, later on, maybe we can create another application, maybe more complex, for doing any kind of analysis, and replace the index.html that is here. So as you see, the action actually put for each commit, whoever put the commit, some information, some ID, and then the metrics that we record, so that this is inside bench, just the things that we dump in the previous step. And then the action wraps everything and creates this file and maintains it. And so it's quite easy to have something up and running, and maybe we'll update this, I think, if we feel so, if we feel it's necessary, and if we want to see more, or for different kind of transaction, if we want to have, I don't know, we could do more. So if we have also some data viz ninjas that do lots of front-end things and that love this kind of tools, know that the data is here, and you can start to work with it however you want, and it's cool.
Yeah. It's a valid point. This is definitely a good source of good first issues, not only to add visualization and stuff like that on the front end, which will be great if some people want to work on that, but also add more kind of benchmarking. Like, for example, Harsh is working on adding NFT benchmarking, but we want also to maybe have different metrics like number of Cairo steps per second, etc. Because we also want to showcase the power of Cairo, which is the computation power of it, and not only the number of transactions. So it's important also if you can showcase the number of Cairo steps per second. This is also an important metric. So that means that there are potential for many issues. Front-end issues for visualization of data, benchmarking, that means adding some stuff in the benchmark part in TypeScript and also in the Rust part to fill the genesis, maybe stuff like that. And also some Cairo code actually to showcase big computation and whatnot. So there are definitely plenty of issues we can do there. Feel free to create issues if we haven't yet about that. Otherwise, we will create more issues. And as a general comment, you also can create issues that you think are relevant. If you think that some place in the code can be optimized or whatever, you think about adding a feature, don't wait for us to create issues. You can definitely take the initiative of creating issues, and then we can discuss together if it makes sense or not. But please help us also to think about the project as a whole, and we want you to be involved also in the direction of the project and the features we will add and whatnot. So yeah, feel free to submit idea about good first issues. Okay, very cool. Yes, Greg, you wanted to do the deep dive on the get events implementation, and then I will speak a bit about the coding principles.
Yeah, sure. Should I share my screen myself, or
yes,
do you...
please?
Yep.
Yes, please. Yeah.
Okay. Okay, so this is the beginning here of the get events route. So first, I have to do a bit of cleaning on the event filter, with page, which comes from StarkNet RS. Since it has some, I mean, it follows the spec, but it's just weird formats, like token is a string. So I just make some conversion here for the from address to keys.
Greg,
yeah.
Greg, please, can you take a step back and explain what is the goal of this RPC, and also explain generally that we have also two kinds of events, substrate events and StarkNet events. It will be helpful to follow the deep dive, I think, if you can take a step back and explain the goal of this RPC
sure.
and the event mechanism in general, please.
Yeah. So the goal here is to match the RPC specs for StarkNet, which allow you to filter StarkNet events which are emitted, which you can emit in your Cairo contracts on StarkNet. And so you need to differentiate those with the substrate events, which are also events that get emitted by the StarkNet, the substrate runtime. I can show you some of these. Can I do that on here? Wait, I think I'll switch to my IDE. Yes. So let's go, for example, to the runtime. Yeah, a little slow. Yeah, for some reason it doesn't want to expand. It's just my IDE that's completely dead. Well, anyway, you also have some events that are natively emitted by substrate. And so first of all, we don't want to take those. So we really want to focus. We're really filtering the StarkNet events. Oh, here it expanded now. You have the here. So these are, for example, some runtime events that are emitted in our runtime. So you have those from the system, which again, yeah, IDE is a bit dead, but whatever. And so here in this RPC, endpoint for get events. We're really just focusing on the startnet events that get emitted during contract execution. So this is the filter you get with the RPC call. So first I get all the different data that I need for filtering. So you have a continuation token, which just allows you to do pagination. You have a from address, so that's filtering on the starting address that emits the event. You have keys, which are keys that get emitted by the events. Usually, I think by default, you get the selector for which is the startnet kit check for the event name, but then you can also add some keys to your events, which you can decide on yourself. And this allows you to filter on all those keys. And then you have the chunk size, which is the size of the amount of events you want to filter. So you have some restriction on the amount of keys you can give and the maximum amount of events you can query. So just checking that this is within bound. Then I need to here get, so from the filter you provided, I need to get the substrate block number, well, the startnet block number for the from filter, the 2, and then I also get the latest block here, just to be sure that that the 2 block you provided here is actually lower than the latest block. If it's not, I just replace it by the latest block. Yeah, just this was actually, I couldn't find this anywhere in the spec, so I just followed what Papyrus was doing. If your from filter is bigger than the 2, it just returns an empty vector of events. So that's just, couldn't find a spec for this, but this is what Papyrus was doing. And after all this, I give this let's say transform down RPC event filter to my filter event function. When I first did the PR which wasn't great, and I think Abdel will talk more about this after, but I had everything grouped into one function, which makes it more difficult to test, more difficult to understand. So I think even this filter events function could be broken down into smaller functions, which is probably a couple of good first issues we could do. But anyway, for now, it's quite a big block. So again, this is just getting the values out of the filter. And then I start iterating on the block range we have. For every block, I get the block hash we have for the substrate block we're at. I need to get the block just to extract the startnet hash and the startnet block number. And then I can pull the events. This was a bit tricky because when I started, I had actually no idea where substrate would store these events. And I eventually found out that they were just stored. So you can see here where I actually queried these events. They were just stored in the system palette under this storage key. So just system, just events. And yeah, so this just queries the storage. You get back an event record. So that's actually also the tricky part, and that's what Abdel asked me to present. Event record can just be any event emitted by substrate. And so after that, I need to map on all these events and filter out the ones that actually correspond to a startnet event. And you can see here the matching. So I match on this runtime event startnet. And even inside of that, I need to match on event startnet event, because for because we actually also have these types of events in our startnet palettes. So only looking for these events, which are really the StartNet contract events. So going back to the RPC, yeah. So here I get these StartNet contract events. And now comes in the continuation token. So if my continuation token is bigger than the block events I just got, I can just skip them altogether. So I just jump to the next block, reduce the continuation token by the number of events I had, increase the index. Index is used for pagination again, and then just jump to the next block. Otherwise, I just skip the continuation token amount for these events. And I can start iterating the events. So in this block, now I'm just filtering out the from address and the keys. So if ever I have an event that matches my from address and the keys that were provided in the filter, I can push this into the filtered events. And then here at the end, you just have the breaking condition. So if I have enough filtered events in my array and my vector, then there's just a last condition that actually checks here if I need to provide a continuation token for this query. And basically, it's just checking where are there any more events in the block event vector. So if there's more events, then you need to provide a continuation token for someone to requery the get events endpoint with this continuation token if they want to keep filtering on the filter they provided. And otherwise, if there's no more events in here, then I just return none. So the filter has gone through all the events. And yeah, that's it.
Okay, thank you. Super useful. Yes, very cool. Okay, Ben is not here, I think, so I will continue and talk a bit about the coding principles. Yes, okay. Can you see my screen? Yes?
Yes.
Okay, cool. Yeah, I wanted to talk a bit about coding principles. It's just the first introduction of this concept. We want to create a full document about that. We started a bit to document it, but it will be, yeah, we will continue to improve it and continue to work on that. And I want to just do an overview of those principles. And then, as I said, we'll try to practice that in action. And for example, during the next community call, we can try to take a pull request on a real code and on Madara and try to apply those principles and think together how we can apply them and try to improve the quality of the code by applying those principles. And yeah, we can go through different concepts every time and see if we want to integrate more concepts, remove them, etc. This is something that will live over time and that we will consolidate, and hopefully we can extract that to something more general for the whole ecosystem in order to try and increase the level of quality of the ecosystem. So I will start by saying that we need to think about the goal of all of that. Like the goal is to have a clean and maintainable and efficient code. We need to keep in mind that the code is much more read than written. A lot. It is a lot more read by people and than it is written, and usually it's read by people that are not the creators of the code. So this is drastically important to have a clean code for maintainability, etc. We draw inspiration from Clean Code book, which is a very interesting book, and I encourage everyone to read this book. Yes. So the idea of clean code is really to help to understand the code better and to improve the quality by reducing bugs and to facilitate the maintenance process. And I would say that it's especially important on an open source project like Madara, where there are many developers working on it, which is great, and we all have different ways of coding, etc. So I think it's very important to try to unify and converge around some universal principles that we all try to apply, and it will make our lives easier and make the quality of Madara better. So some example, like it's important to use meaningful names, to always think about the business logic of the code, actually, because the code must mean something concrete and real, which we should try to encourage small functions, apply some principle like the don't repeat yourself. Obviously, we want to test the code well and have meaningful comments that provide some value. So it's very important to focus on, the business logic of the code we want to write, and it's important to document it well. Some example, like for example, this is an example of the clean code principle in general. Like the implementation is straightforward. There is nothing superficial or not necessary. It goes straight to the point. It's simple, and there is each function has a small scope of responsibility, which is good for maintenance because it helps. For example, simply when you do a code review on a pull request, for example, it's easier to do a code review on something that is small. So the first principle is KISS, keep it stupid simple. Keep it simple, stupid. The idea is to really keep the design very simple and avoid any kind of unnecessary complexity. Sometimes we try to kind of overthink stuff and we want to have abstraction everywhere. We want to make the code generic, etc. But sometimes it's error prone and it decreases the quality of the code, and it's harder to read the code and to understand it. So simple is good, actually. So keep it stuff simple is something good. So try to do the most straightforward implementation is always better. And a comment on Madara specifically, it's not easy actually to apply all of those principles. Why? Because we are using a framework that is Substrate that has its own complexity, assumptions, mechanism, etc. So it's not an easy exercise actually to apply all those principles, because by nature, when you have a framework that is as powerful and flexible as Substrate, it obviously comes with some abstraction level and whatnot, which necessarily implies some kind of complexity. So we need to play with that. And this is an additional reason to keep stuff simple the maximum possible, because we already have some kind of underlying complexity. So I will say that it's even more important to keep stuff simple. Then the second principle is Yagni. You aren't gonna need it. So basically, again, we tend to think long term and we want future-proof design and whatnot. But actually, oftentimes it's better to never add the functionality until it is really necessary, because it's likely that you can think about the future that you think might be needed in the future, but there are many chances that it will never be the case. So you would have added unnecessary extra complexity. And if you add some stuff that are not necessary, you will need to test them, etc. So the complexity will get bigger and bigger. So only add the functionality when it's necessary. This is another principle. A simple principle is the dry, don't repeat yourself. This is the base of the software engineering. Obviously, when you reduce repetition, it lowers the chance of bugs. it makes the code more maintainable, because if you have a bug, you will fix it in one place. So this is a very simple example that follows drive. So for example, instead of having a function that add 10 and another one that add 20, obviously it's better to have a function that add any kind of n. In order to avoid repetition. Obviously, this example is obvious, and everyone know that it's obvious, but it's good to illustrate with a simple example. Then SRP, single responsibility principle. I think this one is very important. The idea is that a component should have only one reason to change and one reason to exist. So you should only focus on one single scope of feature. And in this example, we have a struct that I will go to the full example. It will be more relevant. Yes. So we have this struct, report that has two functions. So I will start with the bad example first. So we have the struct report with some data. It has new and a print function, but it also has the format function. So it mixes kind of responsibilities here, because there are some functions that are responsible of data handling, like new and format. And there is one that is responsible of output. So for example, a better approach would be something like that. You have only data handling function in the report, and then you have another struct that is responsible of the output. So try to have only one scope of responsibility, and a good way of knowing if there is one scope of responsibility is there is only one reason to change something. And it helps a lot. We can apply this principle for pull requests, for example. We don't want to mix different issues on the same pull request or different features. It's better to to have only small pull requests, because it will fluidify the code review process. Because obviously it's easier for a reviewer to review a small pull request, so it has a lot of benefits to only small pull requests that are focused on one single change. And it's easier to test, to review, it's easier at all levels of the process, so it helps a lot. So in conclusion, for this first introduction of that, those are principles. They are not strict rules, obviously, and we can see them as a guide towards a clean and maintainable code. And the idea is to try to write some clean and beautiful REST code together. And as I said, the idea is to make it something that will live, and we will all work together to improve the documentation and help. For example, when we onboard people, we can start also to educate them about the principles we want to have for the project, etc. And hopefully in few weeks, few months, when we have something that is very solid, we can try to share it more broadly on the ecosystem and see if we can get adoption. I think it can be beneficial for the whole ecosystem, basically. So this was only a small introduction. And again, we will go more deep dive and more really concrete and illustration of those principles in action on actual code. So we'll try during the next community calls to deep dive on some concepts and how to apply them in action and how to improve those. And for example, it can be also a good source of good first issues. You can try to think again. Let's say, for example, 2 weeks ago, you did a pull request, you did it in a certain way. Now you can try to think and explore and study a bit those principles, and then you can try to do the same change again, applying those principles. And I will be happy to consider them as eligible contributions because it will improve the quality of the project. So if you want to contribute and you don't have any concrete idea on how to do a thing, or you can take an existing code and try to apply those principles to improve the code and document in the pull request why you think this change is better regarding the principles, and then we can discuss about it. And if yes, we can merge the code and try to improve progressively the code base. the code base. So yeah, that was just a first introduction about those principles, and hopefully we can work together on improving those. Okay, Lucas, do you mind sharing a bit about the first flame graph and the performance bottlenecks and what is our plan? Because one of the main focus of the coming weeks will be performance. We'll update to the latest version of the Blockifier to integrate Cairo 1, but we want to do big work in terms of performance optimization. So we will need a lot of help from all of you. It will be interesting because you will have to manipulate tooling to measure performance, debugging and whatnot. So I think it can be interesting. So Lucas, please, can you share a bit about the flame graph? Even if you can show just how to run it and get the result and how to interpret it quickly.
Okay.
Thank you.
Okay. So to have the flame graph, you need to install the Rust flame graph thing. So you go here, you follow the install instructions. It's not hard. And then you run Madara with...
Can you say something about your branch names, Luca, maybe?
No. Okay, so you run the benchmark. It's type your password. Blah, blah. You wait for a bit of execution, and then it will generate a flame graph. And actually, I'm gonna save the old one because it's useful. And okay. So here it generated a new flame graph, which you can see here. But we're gonna use the old one, which is somewhere here. Which is here. And this is what the flame graph looks like. So to explain how it works, here is the whole execution. The longer a line is, the more time it takes during the execution. So here it's the whole run I did. So this is the function that runs the rest, and you go up, and then you can see in more detail. So for example, when you have a transaction that arrives in the transaction pool, this function is triggered, and then it calls this one, blah, blah, blah. And here we see that validate and signed takes, I can't see because there is the zoom thing, but it takes a lot of execution, so probably like 60% of the execution, we don't care. And here we can go here, and it says, okay, it's this function decode vec with len takes 41% of the execution time. I don't know if you can see, but this is that, and this function calls these two functions, which call this two function, and in the end, what's taking a long time is to create a field element from a byte slice. So this is a problem, and you can see here it's the same thing. It takes 10% of the time here, and 6% of the time here, and in the execution also it takes a lot of time. So this is caused because we changed the field element type we use. So before we used the U256 from substrate, which was really optimized for serializing and deserializing. Ours is not optimized at all, so it caused like a big slowdown in TPS, and I'm currently changing back to U256 to see how much it improves things. And we also need to think about that when we'll use the new unified field type. Yeah, that's it basically.
Okay, thank you. Ben, conclude. We will finish by Ben.
Can I ask a question?
Oh, yeah, sure, of course.
I have two questions actually. Just first regarding this field element type, the ongoing work with StarkNet RS, Jonathan, Lambda class and stuff. I guess, showing benchmark with like 20 times improvement in some different operation for the field element. So maybe we can expect, can we expect to have this as well in substrate, that it's not necessary to go back to U256, or it's another kind of optimization?
It's another optimization. So they are optimizing for the operation. So for the VM, it will improve the speed of execution. For hashing also, it will improve. But for serialization, they're not benchmarking this yet, so we don't know.
So it might
but
be
it's-
worth maybe adding something in the benchmark, because at the end of the day, if there is a bottleneck using these types in some context, maybe it's important to track this as well.
It is, yes.
Yes, definitely. And the idea of the universal type is also to try to provide some efficient conversions for serialization. So we try to use some unsafe transmute techniques in Rust to try to go very low level to do optimization. And on this, we might need the help of people that are experts in substrate to see if we can integrate very smoothly this felt type. So Lana, Justin, if you know people that could help us on designing the most efficient way to represent the felt on the substrate architecture, both on the serialization part and all processes related to substrate, that will be very helpful. So
there is an issue to actually improve the scale encoding. Because right now, like the scale encoding of the field element is a bit, it's like a naive implementation that Gleam did. But it could be, as Timothée has a bit more context there, but basically it's it doesn't really scale encode it. It just makes it compatible with scale encoding, but it doesn't make it a compact type, and so you don't gain any performance from it. Whereas scale encoding is supposed to give you a lot of performance boost. So I don't know. I think Glim, you're working on this issue, right?
This is a different issue. Scale encoding with like a tiny, like what you're talking about is like reducing the size of the encoded type. But here the problem is that to create a field element from a byte slice, it's super slow.
Yeah, no, it's a different problem, but I was just mentioning this as well. So I don't know, Glim, by the way, if you gave an update on this. I don't know if you're here.
I don't think Glim is here. Maybe I'm wrong.
He was here, no?
Oh, really? Okay. He's not anymore.
He might have left, but yeah.
So
just
who to get some more context about it, and if there's some stuff that we could help with.
Okay. So basically the felt element we use everywhere in StarkNet is so on StarkNet and Cairo, this is modular arithmetic everywhere, and everything is so the felt is basically a 252 bits number, and every operation is done with this felt, and we don't have right now an efficient way to go from byte slice representation of this felt to the actual felt that will be used by the Cairo virtual machine to run the Cairo programs. That means that we receive some byte slice from substrate, extrinsics, and all substrate part, and then we need to convert them to the felt elements to do the actual execution on the VM. And here we lose a lot during the conversion. So as Timothée said, we would want to use maybe the Montgomery representation of the felt, which is an efficient way of representing these field elements. But we need to investigate on how to do that properly with substrate. Yes, a good way could be to use transmute, and that will be a very smooth conversion. Without doing any process. Actually, it will be just a copy in memory at the right place. So it will be unsafe code for sure. But if we document it properly and we know what we do, we can likely gain a lot of performances. So we need to write the proper documentation about the problem and the potential solution, and then we can share it with you, Lana, Justin, and see if we can find a good way to do it. Does it make sense?
Yeah, definitely. Yeah, maybe we can help with something.
Okay. Very cool. Okay. Okay. And last but not least, Ben will do a deep dive into the Simulate Fee RPC implementation.
Hey, everybody. I'm actually going to be doing estimate fee. Because right now, as a lot of the infrastructure providers don't actually expose simulate transaction, we're going to go ahead and not support simulate to start with. But we're going to add it as soon as StarkNet RS has support for simulate types. So cool. We'll be doing estimate fee on the left pane here. Can you guys see my screen?
It's a bit small.
Okay, let me. Is that better? Okay. So yeah, we should know how to define the RPC interface. So I'm not going to go over that. I bet. Give me 1 sec, okay? So this is the actual method for implementing the estimate fee. We're going to take a broadcast transaction, which I'll show you what the enum can be, and a block ID. So we get the best block ID from the substrate. This is just a utility function we have earlier. We get the best hash here. So 2TX, we'll go over this. This is kind of an unfortunate utility function that we have to have instead of kind of the idiomatic into or try from in the utils here. So we take the broadcast transaction, which can be either invoke, declare, or deploy account, and parse it out. We have formatting for these because these actually get exposed in other RPC calls. So to invoke function, we make an invoke transaction. To deploy account, we make a deploy account transaction that we use for types internally. So that should be pretty self-explanatory. We get the transaction from that. And then here you'll see that a lot of write RPC functions build out an extrinsic and submit it to the pool. Since this is a query function, we're just looking to get what the fee would be from this transaction. We're not looking to actually submit it. We can use a runtime API. So we use a runtime API that exposes estimate fee from the runtime. And that way, when we execute this, it's a shadow execution, and it's not actually submitting anything to the pool or changing any state. Cool. So we'll go into that. This is estimate fee from the runtime. Sorry, from the crate. Yeah, since we've built the transaction out and we understand which transaction it is, we can just execute, and then we get the call info around that. So what was the gas usage? What was the actual fee? Right now, there's another issue that's open that I believe someone's working on to actually have to call an off-chain worker to get the L1 gas price.
Gas price, yeah.
So right now that's hard coded to 0, but this will eventually be populated. Cool. So I want to get into this comment just briefly. The way that the current tooling works is that since this is a query transaction that we're submitting to the pool, everyone can see it. And so if we sign this transaction, everyone gets a good signature, that someone signed with their private key. So the way that this was discussed when tooling was first built, like StarkNet RS and a lot of the libraries, is to populate this with this transaction version that's a fake transaction version. In the high 128 bits, we have a 1 here that's set that makes this not a valid transaction on mainnet. So what we would like to do in testing is we would like to build out an account just the way that we normally do with estimate invoke fee from StarkNet JS. But StarkNet JS under the hood has this hard-coded fee transaction version, which with the upper 128-bit set, which is not valid. So instead of being able to build that out, unfortunately, right now we have to just call the RPC manually. So we do that here with this version of 1. The problem being that that becomes a valid transaction that everyone can see that's signed with the correct nonce. So we eventually need to fix that. But again, that'll be fixed upstream in StarkNet RS. Yeah, so that is what I have for estimate fee. Let me know if you guys have any questions there.
Thank you, Ben. Very helpful.
I can't remember exactly, but there was normally this newly introduced don't validate signature Boolean or something like that for the validate, or being able to validate transaction estimate fee with the signature, isn't it? Like a month ago or something like that, I did in StarkNet.
If you can point me to that, that'd be great. This is the current implementation from StarkNet RS. So, and he said, and Jonathan said that he's going to support it in this version with the upper 128-bit set. But if you can point me to that documentation, that'd be great.
Maybe I'm hallucinating. Let me.
No. I think there was a skip validation where instead of where you would just execute and you would skip the validate for the account. I think it's already available on testnet.
Okay, then we'll need to spin up an issue to support that, because that would be the better implementation in my opinion.
There is a skip.
Okay, we need let's try to check. Okay, thank you, Ben. And yeah, maybe to finish, Antiro, I don't know if you want to tease a bit about Deoxys or not yet. You want to talk about it a bit, or Antiro, if you hear me?
Yes. Yes.
You want to talk about it?
Sorry, I was in the other room with the Elias. Can you just repeat your question?
No, my question was, do you want to tease a bit about the Deoxys project or not yet? Yeah.
So so with this team, actually I am with Bora, Zarbox, Sparkey, and Betacode. We are trying to export the client of Madara to StarkNet, so to make peer-to-peer available sooner than Pathfinder, Juno, and Papyrus. And if eventually Madara is integrated as the main sequence of StarkNet, we will have the chance to be compatible with it. So the goal is the project is named Deoxys. Our goal is to take the funnel client from Madara and export it to StarkNet. Right now we are doing some proof of concept. We started this week. We already managed to convert to bridge the API gateway blocks to substrates to convert them. We are still trying to receive them correctly, but it's going well, and we will open the repository soon. Like it's already open, but we will open some issues and all soon, like this weekend or early next week. So if you want to come and give a hand, don't hesitate, guys.
Very cool. Okay. Thank you very much for this. Yeah, and also you guys are working on the StarkNet stack as well, especially on the faucet. If you want to give an update on that.
Yeah, so we are also working on the StarkNet stack. So we are implementing the faucet. It's Zizou actually, one of the Casa Labs dev which is integrating it. He already integrated, I think. So the image is available. You can already implement it it's already implemented to the StarkNet stack. We are also working into integrating checkpoints from Snapshot Labs into the StarkNet stack. The Docker is in progress, almost done, should be done by the end of this week, and ready to be integrated to the StarkNet stack also, yeah.
Okay. And as I was saying to Pia, the StarkNet stack will be way better than the OP stack. It will be more secure, and it will have more computation power, and it won't have the drawbacks of optimistic rollups like the dispute period and stuff like that. So definitely, I'm excited to see the StarkNet stack in action. So yeah, Pia, you want to say something?
Oh, I'm just like curious about like right now. I think I mentioned in the like Madara or like Hakaru group that after the everything will more and more like L3 like upchain, this kind of narrative, then like just like people right after like roll up came out, people like start thinking about like cross-chain messaging and like bridges, this kind of like new definition to like interoperably access to each other's data, right? So I'm just like, yeah, thinking about like what would be happen like after the Starknet, Kakarot and Madara, like this kind of stack, like Starknet stack is more mature, and do we need the like needs people, like I think people will need to like access in between these stacks. So is it
Yeah.
possible? Or how can we like match the fraud proofs and then validity proofs? Yeah, so yeah,
Yeah.
that's it.
Okay, interesting, very cool. And actually, one way to do this kind of interop is through what you are building at Herodotus, because you provide solution to prove what happened on optimistic chains and whatnot. So yeah, this is definitely a possibility to build this kind of interoperability and composability between the stacks. So yeah. And this is why we need to keep supporting Cairo 0, because you are using Cairo 0, and you can.
Actually, right now, what I'm doing is I'm migrate. My task is migrating the Herodotus stack into Cairo 1.
Oh, really? Amazing.
Yeah, yeah.
Okay.
I'm working in the progress. Yeah.
Oh, nice. Very cool. Okay. Yeah. I think the biggest blocker you will have is the lack of arbitrary hints in Cairo 1, but we are trying to think about ways to maybe implement a God mode or unsafe mode in the Cairo compiler that will enable people to use their arbitrary hints. But yeah, I think this will be the main blocker for you.
Yeah.
But very happy that you started the migration. Yeah.
It will be solved really soon. Ori from the compiler team invited me to do a pair to the repository to introduce a cheat code int that can basically do anything. So he gave me the signature, and it will allow users to write totally arbitrary ints. They can just then
wow,
the selector,
that's huge.
Do whatever you want, but
you drop alpha like that, like nothing. It's interesting. Very cool. It's amazing. Honestly, I don't know if people realize, but it's huge. If people can use arbitrary hints in Cairo 1, this is really something big. Okay. And yeah, to be clear, it won't be possible to do it on Starknet for sure, because for Sierra, for the public Starknet, we don't want to enable that, because we want to have only provable transaction, because this was the whole purpose of Sierra. But for client-side proving or app chains, Starknet app chains, it will be possible for them to use arbitrary hints in Cairo 1, which is huge. So yeah, very cool. Okay, thank you for the alpha, both of you, Pia, the alpha of Herodotus migrating to Cairo 1, and Timothée for the alpha of the cheat code hints in Cairo 1. Okay, anyone want to add something? Question, comment?
I just had something we didn't talk about. I was curious who would like to maybe work on that. It's about the state migration. So like taking the Pathfinder snapshot and starting out a Madara chain from this snapshot.
Yes,
yep.
I think this will be the natural continuation of the work by Kazar Labs, actually, because once they have the Oxys, they will be able to start from an existing snapshot. They are already implementing the reading a snapshot of, maybe they have not started, but they plan to do it. So this will be the natural continuation of their work, and that once we have that, it will be easier to start from an existing state. And yeah. So
okay, perfect.
Okay, very good. And maybe you want to talk to invite people for the hackathon to have the registration started, or?
Yes, yes. Yeah, for maybe people here who don't know, so we're running a hackathon, Cairo One hackathon, and basically a Starknet hackathon in general. So if you haven't registered yet, there is a Madara track. There are tracks for everything. Yeah, so feel free to go. Here is the link, and yeah, hope to see all of you there.
I was thinking about something funny, because when I saw the list of sponsors, I realized that it's funny that Madara is a gold sponsor, because Madara is not a company or someone, and Madara is a gold sponsor of the hackathon. This is very funny and interesting.
Well, people are low on cash, and the inspiration team is fueling the innovation. So
Interesting. Okay, I guess we can